Alright everyone, welcome to video 2. We've just finished filling in the cost portion of our worksheet, and you graph total cost, variable cost, and fixed cost. Now I'm going to talk about what those mean, and then we're going to look at costs a little bit differently that might be a little bit more helpful for profit maximization modeling. But first, let's draw our total product curve. I'm going to summarize basically the graphs we've drawn so far. So total product curves usually look like this, right? And our total cost curve, which puts quantity down here and asks, well, how much does a unit of output cost me to produce? They look interestingly opposite. Let's talk about why that's the case. Well, so far we have learned that the change in total product is the marginal product of labor. Or change in total product curve is the marginal product of labor. So through our game we learned that marginal product of labor diminishes at some point. So in the beginning we might hire just one worker and they're pretty productive, but they're trying to do everything. As we hire more workers, each worker gets increasingly more productive. So think about if you're a pizza joint and you have one worker who is baking the pizzas, making the pizzas, selling the pizzas. They're not going to be able to churn out that many pizzas. Then we hire another worker, and one worker does prep while the other one does baking. And we hire a third, and they're each going to be more productive. Right? But in the short run, we've learned that capital constraints can really harm our ability to produce. And so, just like in your tennis ball game, when we tried to hire more workers, we ran out of space. We didn't have enough machinery, we didn't have a big enough room. And so what happened as we hired more and more workers? Well, eventually that productivity starts to fall again, right? Diminishing marginal product of labor. So, when we're thinking about costs, the cost to produce different quantities of goods doesn't just change at a constant rate, right? It doesn't just go straight up. This constant increasing cost. I want to produce one unit, it costs me the same amount as I produced the 100th unit. Not true. Why? Because of the way the returns to hiring workers in the short run. So if I choose to produce a very small amount here, Q0, the marginal product of labor is pretty small, but improving. As I hire more workers to produce more quantities, the slope of the total cost curve gets flatter, right? So my costs are growing, but they're growing at a slow rate. Then what happens as I continue to produce more and more? Well, each worker is increasingly more productive, but then we get like to this tipping point where workers start becoming less productive than the ones before them. That here is kind of like this flipping point on the total cost curve, right? Each worker is so productive that costs really slow down, right? Those marginal costs are falling, but then as I try to squeeze more output out of my factory in the short run, those workers start running into each other. We start getting inefficiencies, and so their productivity falls. So what happens here is, down here, maybe one worker, and we saw this in our graph, they produced 5.5 tennis balls a piece. When we had just 2 workers, they each produced 5.5 tennis balls a piece. Later on, however, we saw that those workers produced only between like 1 and 2 tennis balls per worker. So, one worker produces 5, one worker produces 2, we're going to have to hire 2.5 workers out here to get the same amount of output as we did when there were fewer workers. So what's more expensive? Getting 5 units of output here or 5 units of output here? At our wage rate of $15, it only costs $15 to get 5 tennis balls out of this worker when we didn't have many tennis balls being made. At $15 a worker, if it costs 2.5 workers to get 5 tennis balls now, right, we're looking at $37.50 just to get the same 5 tennis balls. Costs really start to explode to get a tennis ball produced. And so that's what happens over here when marginal cost ticks upward. At some point, we have diminishing marginal product of labor set in. And so that's what's going on over here. In this portion of the graph, we have diminishing marginal product of labor. The slope starts falling for total product. Each worker is getting less productive than the ones before them. That correlates with increasing marginal cost, additional costs, and so total costs keep exploding. By the way, I've kind of got ahead of myself in abbreviating these. We'll formalize this a little bit sooner, but marginal cost, MC, is marginal cost. That equals the change in total cost over the change in quantity. So hopefully now you're getting comfortable with the idea that marginal means slope, right? Marginal means change. And so marginal product of labor is the change in output over the change in workers. Marginal cost is the change in cost over the change in output. So, in sum, total costs grow slowly and then explode because of what's going on with worker productivity. When we have very few units produced and we have marginal product of labor increasing, well then each worker is doing a lot of stuff with their wages. So those costs are going to grow very slowly. But as diminishing marginal product of labor sets in and workers start becoming additionally less productive, it's going to cost more to get the same amount of output out of them. And so costs start exploding. So there's a tension here, right? We talked about that tension in profit maximization where firms want to generate revenues by selling stuff. And even if they can sell even if they can sell as many as they want at a given price, worker costs are going to make it so that they don't sell an infinite quantity, right? Look at these things exploding. In fact, you found that in our game, the cost curve bent backwards. There is an opportunity to produce less stuff at higher cost. You just hire too many people. I made the curve stop here because it's not useful to be on this portion of the curve. If we're going to produce, and I think that example was like 29 units, we can do it cheaper than overhiring, right? Okay, good. So that's the relationship between, in fact, one thing you could do is if you just rotated total product on its axis like that, it would look just like the total cost curve, right? That's the relationship.